Okay, Algebra 2, this is part 2 of the video. We left off here on the 10th example problem. It's another break the combination question, another cross them up and split the middle question, in other words. But once again, it's in quadratic form. So I don't know how to factor this quartic or degree 4 polynomial, but if it had been a quadratic, if it had been x squared minus 10x plus 24, then I would know how to do that. And you can cross them up or not. Either way, you should find the factors are x minus 4, x minus 6. Remember that minus 4 times minus 6 is plus 24, and minus 4 plus minus 6 is negative 10. So x minus 4, x minus 6 would be the factors if it had been a quadratic, and all you ended up having to do was double that exponent, put it back up to the same, take it back up to the same level that you'd taken it down from. So you chopped 4 in half to make it x squared. So now you had x minus 4, double that exponent on the x, make it x squared again. You've got x squared minus 4, x squared minus 6. This on the left, though, remember, is another perfect, it's another dot, it's another difference of two perfect squares. So you're actually going to have x plus 2, x minus 2 on the left, and x squared minus 6 on the right. Those are the factors. Now, when it comes time to solve, you've still got those same three factors here. So x plus 2 could have been 0, x minus 2 could have been 0, or x squared minus 6 could have been 0. On the left two, if x plus 2 or x minus 2 had been 0, then x would have been plus or minus 2. But on the right, if x squared minus 6 had been 0, that would have meant x squared would have been equal to 6, which would have meant x would have been equal to plus or minus 6. So the answers that you have here are 4. Minus 2 is one of them, positive 2 is another, plus square root of 6, and minus square root of 6. Those are the 4 possible answers for this example. 11th example, there are only 12, so we're almost there. If you ever have 4 terms, remember, you can always split the left half from the right half, assuming they're written in standard form, from highest degree working downward. So on the left side, I would have been able to factor out x squared, and I would have had x plus 3. On the right side, I would have been able to factor out 2, and again I would have had x plus 3. So then one of my binomials is x squared plus 2, another is x plus 3. The reason I know that I'm done this time is because I can't do anything with x plus 3, and x squared plus 2, well, that's not a perfect square there on the right. And there isn't any other rule that I know for how to factor x squared plus 2, so that's done. So those factors then, if it had been a solved question, would have been equal to 0, which means it could have been x plus 3 is equal to 0, or x is equal to negative 3, or it could have been x squared plus 2 is equal to 0. On the left case, if it had been x squared plus 2 is equal to 0, then x squared would have been equal to negative 2, which means x would have been equal to plus or minus the square root of negative 2. I factor out I. I've got x equals plus or minus I root 2. And so my answers are negative 3 and I times root 2 and minus I times root 2. You could have stopped here and written these as your answers, and that would have been fine. Last example. Another set of 4 terms. Split them in half. Once you've got them written in standard form, don't be tricked if they're ever not written in standard form. On the left, I can factor out x squared. And on the right, I can factor out negative 4. And so now I've got, well, putting those together, I'm going to have x squared minus 4 times x minus 1. Notice that this is a dots, as we're now learning to call it, difference of two squares. So it's x minus 2, x plus 2, times x minus 1. That's factored. If it had been an equation you'd been asked to solve, then you would have had those same 3 factors set equal to 0. And this one's easy. X could be, well, let's just jump right to it and uncover everything. X could be negative 2, or positive 2, or 1. Those are my 3 answers. I'm done. And like I said, that was my last example. I know I've gone through this relatively quickly. I meant to, maybe not as quickly as some would like, But again, I'm trying to make these 15 minutes long. In this case, it wasn't possible. But if it went too quickly for you, don't hesitate to come in and ask questions. Take as much time with me as you like outside of class. But I hope the video proved helpful.